You know, you shouldn't be getting here later than the 9:30 because again, that really does cause a problem because it takes away my time to have to figure out who's coming in, and I have to go to a different screen on my computer. And so there's just not the time, the luxury that I would like to have. All right. Um, I got a head start on lesson two only because I thought most of you have done Chief Sokotoa and knew about which ones were that. These were over here. No, these are the X's and the Y's. Where's my over here? Where you did the opposites and you did the adjacents and you did the hippopotamuses, and you knew those basic. You may only did sine, cosine, and tangent. There's a possibility your geometry teacher didn't do cotangents and didn't do cosecants. And so those were over here. Here's your cosecant, your secant, and I don't know why I did cotangent way over here. But the harder part might be where all of this came from because you may not have done that. So, I'm just going to make up any triangle in any quadrant. I'll just go over here. I'm going to drop my reference angle to be there. That's called a reference angle because even if I went all the way to, let me do 210. What if I go 210 degrees? You're going to learn that in this quadrant here, we really only worry about that angle that is touching the y-axis. Just like you would only use down here, you would use that angle. And you probably wouldn't use the negative. You probably would go all the way around and use the positive angle. Too many people getting here different times. Make sure I hear a ding. They ever got in? Okay. Guys, please try hard to get here on time. There's not enough time for me to get through all the pre-calculus topics. And so by having to stop and go back and stop and go back or repeat myself of something I said, you really, this is the college class. You really need to be here on time. It's the first class of the day. Set your Apple Watch or your Android Watch to 9:27 and start logging in around then so that way you're here on time and everybody I don't have to tell everybody, okay guys, keep signing into the chat because I've been saying it, but if I don't say it, people don't do it because not every teacher makes you do it. I'm doing that because I can do the attendance at lunchtime or after school. I don't have to do it right now. And so please try to get here on time. Back to where I was talking. So you got distracted. We talk about the reference angle being the angle that we make from the horizontal line. So if this whole thing is 210, and I take, I take 180 away because this part right here is 180. So that means this reference angle is 210 minus 180. That's really a 30-degree angle. And you've dealt with 30-degree angles in your geometry class. You dealt with a 30-degree angle. And you should have learned that across the street from a 30-degree angle is a 1. The hypotenuse will always be a 2. And the adjacent side, this was the opposite of that angle. Remember, we're talking about the angle that I care about. And this is my hypotenuse always because it's opposite of the right angle. And then this is next to the 30, so we call it the adjacent. Okay? So when we label the values of a special triangle, this is called a 30 by 30 I'm sorry, 30 by 60 by 90, 30, 60, 90, because they have to add up to 180 inside. So this is a special triangle, and across the 30 is always a 1, and the hypotenuse is always a 2, and the adjacent side next to the 30 will always be, let me see, does anybody remember?
Isn't it a 1?
No, the 1 was actually across. I know what you're thinking of, Mr. Genius. You're thinking of a 45-degree angle, whereas the opposite's a 1, the adjacent's also a 1. And then in this triangle, the hypotenuse was always the square root of 2. Remember that? I think that's what you were thinking. But the adjacent is not square root of 2. It's a 1, 2, square root of 3. That's a special triangle. This is a special triangle. These two special triangles, if you memorize them, you got so much a head start of trigonometry. Okay? Well, with that being said, down here, I purposely made a 30-degree angle as my reference angle. That way I could have said, this is not even in today's lesson for real, okay? Across the 30 is a 1. Across from the 60 must be the square root of 3. And then the hypotenuse is always a 2. And the reason that I can do this is I can now talk about my sine of theta. Here's theta right here. It's this right here. Here's my theta. And in this triangle, you could say, oh, it's opposite over hypotenuse. Yes, you can. But the textbook isn't talking about the special triangles. He's just saying for any angle, it could be a 10 degree, a 16 degree, it doesn't really matter. He's going to say, generically, it's this value is a y value, this value is an x value, and then your hypotenuse is considered called an r. So in the textbook that we saw, we're going to say the sine is y over r. So I'm not going to go into any answers of what that is right now. I mean, the answer is still going to be 1/2 for sine of a 210-degree angle is almost the same, but we use the sine of a 30-degree because that's the reference angle. The problem is that y in this problem is a negative y. That x in this problem is a negative x. So depending on where you are, which quadrant you're in. So the sine of 30 is a plain 1/2. Oh, you know what? It's still a 1/2 in here. No, it's not. It's a negative 1/2. The actual answer for the sine of 210 would be a negative 1/2 because this is a negative 1 and this is still a positive 2. Why is that still positive? This is what the book also did. The book said that those angles that I'm talking about occur on this unit circle. It's a unit circle because the distance from here to here is 1, and the distance from here to here is also a 1 because they are the radii. Well, what if I move that radius, and I open that angle up from the radius being 0 to 1, what if I go around the circle and I'm over here? So now I'm opening that angle up to here. And what if, well, I'm going to say what if, who cares, because they're not doing measurements right now. That means the triangle I'm worried about is this triangle, and there's my angle. So if this is my y value, and this is my radius, and this is my x value, in the lecture notes, I didn't talk about it, but he said r was equal to the square root of x squared plus y squared. I think I'll look at it. Let me see. It's on the other page. He put it right here. There it is. And I didn't talk about it because I was just trying to get you to remember the sine, cosine, tangent. And then I said, well, sine, cosine, tangent over here. But think about it. If this is my x, and this is my y, and this is my r, because it was formed from a circle. It's an equation of a circle, and then if I make this triangle using, I better do it over here, using, no, I don't want to do that one. I want to do that triangle here. And there's that point going around. If this is my x, and this is my y, and this is my r, Pythagorean theorem says it's the right triangle. So x squared plus the y squared has to be the radius squared. Solve it for r. R equals the square root of x squared plus y squared. That's where all this stuff came from, okay? So I already went over a little bit of why we're using x's and y's, mainly because you are on a unit circle and you're labeling these distances as x's. In this case, this x will be negative, this y will be positive. But if I'm over here in quadrant 3, just for fun, if I'm over here and this is my r and this is my, it's going to be a negative y, a negative number, and this will be negative number. The tangent of this angle will still be positive because tangent was opposite over adjacent, or y over x. And they're both positive numbers, so it'll still be positive. Matter of fact, there's a sentence you can remember. All students take calculus. Every angle in this quadrant is positive. In this quadrant, only the sine is positive. Starts with the letter S. This is a T for take. So T stands for, take a guess, tangent is positive. This quadrant, if it's down here, starts with a C. Only the cosine is positive. So it helps sometimes to memorize all students take calculus. That way, when you draw an angle somewhere, and you just, you draw an angle here and you want to know if that angle if the sine of that angle is the sine positive. All students take calculus? No. Sine will be negative. If you want to know about the cosine, I don't know why my pen's not writing. The cosine, all students take calculus? Yes, that's positive. My Apple Pencil is just, the tip is wearing out, and I think it has to be replaced. And they're hard to find. You got to get them on Amazon. Cosine is positive. If I want to do tangent, all students take calculus? No, it'll be negative. If I want, and so I don't want to go further with cotangent because it doesn't matter. Cosecant will be identical to the sine. Cosecant, secant will be positive, and cotangent will also be negative. So a lot of information that you may not need right now. My wife says my brain is just so full of useless information. That's what she says. You know so much, but nobody cares about it. I said, thanks. I guess you only care about things that are important to you. Find the functional values of an angle. Okay, we are going to do it today. The terminal side of angle theta is a standard position, passes through this point, 8:15. Find all the values of the 6 trigonometric functions. Yay! Okay, so let me draw and realize he wants the angles to go through 8:15. So I got to find 8:15. Okay, so bear with me. 8:15. So what does that imply? If the terminal side, remember, here's my initial side. Here's my initial side. It's going to open up, And the terminal side is going to open up, here goes, open up, so that the angle, the terminal side of the angle, passes through that point 815. So that point's very important. The point is very important because if I drop my perpendicular down to create this right triangle, and remember, we're always making the right angle on the x-axis, the horizontal line. So there's this angle here that I don't even know what the angle is. But you don't have to know, because I know the x value is 8, the y value is 15. So really what I'm looking at is nothing more, if you did it like in geometry class, and I gave you this triangle, and I said that's theta, and I told you that the x was 8 and the y, not the x, the adjacent was 8 and the opposite was 15. That was the opposite. I am positive your geometry teacher said, find some trig values of this triangle. So I start out, sine of theta in this picture would have been opposite over hypotenuse. With this picture, sine of theta is y, because that's opposite, y over r. This is always called r when we put it on the xy plane. It's the same numbers because y over r would mean 15 over r. Opposite over hypotenuse means 15 over hypotenuse. Well, I want to know what sine of theta is. I don't know r. How would I find r, or the hypotenuse? Please tell me, somebody.
Pythagorean Theorem.
Yay, Pythagorean Theorem. Might need your help because I don't know those numbers. That would be 15 squared plus 8 squared has to be r, or this is 8 squared. Over here we would say 8 squared plus 15 squared equals r squared. It's the same work, guys. So 8 squared is 64. 15 squared, I think, is 225. Is it? I don't know.
Yes, sir. Yes.
Oh, okay. See, again, my brain is so full of useless information. The answer was there, and I wasn't even sure if that was the answer. R squared. Add those up. 289 equals r squared. And did I add it right? 60, 70, 85, 6, 7, 8, 9. So how do I get r? I take the square root of what? Anybody?
17.
Oh, it comes out to 17?
Yeah.
I didn't know 17 times 17 was 289. Did anybody know that? I'm just curious. Did anybody know that? I didn't have it memorized. I kind of am done on 15. 15 is the highest I think I can go. And I'm not even sure I can do 14 squared. I think that's 169. No, it can't be. 16 squared, I don't know. I mean 14 squared, I don't remember. Oh well. I guess I don't have as much useless information as I thought. So now I have my r. So what I'm going to say, that's the first thing I had to do. So here goes. Sine of theta must be 15 over 17. The cosine of theta must be, now remember what cosine is. Cosine is x over r. In this case would be 8 over 17. Tangent of theta must be, wasn't that y over x? And that would be, my y was 15 over the 8. There's 3 of them. Keep going. Because we've learned that the cosecant is the reciprocal of sine, so that's going to be 17 over 15. The secant is the reciprocal of cosine. That's going to be 17 over 8. And cotangent of that angle will be the reciprocal of tangent. That's 8 over 15. That should be the 6 answers that the author wants you to know. So what's my rule of thumb? Always find out what the radius is or the hypotenuse is, whatever you want to call it. That way you'll know what x is, you'll know what y is, and you will know what r is, and you can plug it into any of these on this. Where was it at? Where was that chart at? Not here. Was it here? No, this is still the wrong page. Oh, there it is. Okay, there's that chart. And it's okay to cheat when you're just learning this. I'm hoping you don't have to cheat very long because I tried really hard to connect it to opposite, adjacent, and hypotenuse. But it's okay. You guys are good. I'm very proud of you. You guys do a good job. All right, we're on example 2. The terminal side of the angle theta that's in standard position passes through this point. Find all 6. Okay. So just alone, if I want to find that point, that's negative, negative. So that's going to be negative 3, negative 4. That point's right here. So what happens is this, I need to drop. The angle is going to go, let's see, how am I going to draw it? The ray has to go this way. So there's your angle, okay? Now, I know that all students take calculus. The only trig function that's positive here is tangent. So when I do my work, I can double check my, my positives and negatives. The other problem wasn't a big deal because we were in, well, it was which one did we do? I don't see it here. What was the other problem we just did? Oh, we did this one right here. Wasn't a big deal because I was in quadrant 1. And that is all. Everything should be positive. Yep, 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 yep. One more. Yep, they're all positive. And it should be. Okay? Because all means everything. This problem here, the only one that's positive in this quadrant, when I drop this down, I got to drop this down. Well, too far. I'm not even supposed to be there. I'm supposed to be here. There. So let me get rid of the evidence that I'm not going that far. There. Yes, the ray does go farther. It doesn't matter. The point is the angle. This angle that I made, that ray, the terminal side has to go through that point. So when I look at the measurements, that distance here is, put it in blue here, is a negative 3. That distance here, the y value, is the negative 4. All I'm missing is the r. So let's do the work. We know by Pythagorean Theorem that negative 3 squared plus a negative 4 squared has to be r squared. 9 plus 16 is r squared. 25 is r squared. R must be 5. Does it make sense that the hypotenuse will be a positive 5? I hope you realize that in a circle, the radius is always a positive number. It doesn't matter where I put it. Okay? So, here goes. Here's my theta. It's that angle right there. It's that small angle between the x-axis and the terminal side. Always. Sine of theta is y over r is negative 4 over 5. Cosine of theta, x over r, is negative 3 over 5. Tangent of theta is y over x, which is negative 4 over negative 3. The negatives cancel out 4/3. Cosecant of theta is the reciprocal, negative 5 over 4. Doesn't matter where the negative goes. Secant of theta is the reciprocal, negative 5 over 3. Cotangent of theta is a positive 3 over 4. So that means only tangent, which would also mean cotangent, they're related, should be positive. If tangent's positive, then cotangent's positive, and it's true. Negative, 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 at least I think my signs are correct. Because that's where we mess up usually, guys. We usually mess up on our signs. So often, many of us get lazy, and we forget that these got negative numbers. Those are negative. Why is it negative? It's on the left side of the 0. Why is this one negative? Because it's underneath the 0. The y is negative. The x's are negative over here. Okay? Questions, guys. This is heavy-duty stuff. What we're doing right now is so important. You will use it in every math class from here on except for statistics. You'll use it in calculus. You'll use it in calculus 2. You'll use it in differential equations. You'll use it in math analysis. It's everywhere now, okay? If you're going to be a doctor, you won't need it. But if you're going to be an architecture or engineer or business, no, you don't need it either. I'm just saying, in math world, it's very important. Number 3, finding function values of an angle. Okay, find the 6 trigonometric functions of the angle theta that's in standard position in the terminal side. Theta is defined by, oh, that looks kind of ugly. I'm not even sure how to start this one. So I guess I'm just going to have to perhaps wing it and see how we set it up. So let me see. He's got an equation of a line. If I graph it, I'm going to use the intercepts that we've learned 100 times. If x is 0, then y is 0. Okay. Is that true? If y, oh, that's just it's going to be a line that definitely crosses through 0, 0. That's not exciting at all. Because if the y is 0, then the x has to be 0. Both intercepts are the same, so that wasn't exciting at all. So I need to graph that line. Okay, I need one more point. Let's do x equals to 1. What would y have to be if that's a 1? Solve it. You should be fast by now. It should be negative 1/2. Am I right or wrong? You should be quicker. If you're not really here, you're going to miss out. So those are 2 points. I'm going to use the 1 negative half. If I'm wrong, let me know. Oh, 1's not there. 1 is here. And a negative 1/2 would be about here.
Sir, why did you replace the x with the 1?
I made up a point.
Okay.
I just made up a point. If you wanted to, you could have just solved it for y. That's the other way some kids do. That 2y equals to a negative 1. No, I'm sorry, 2. If I go back to the original, if x plus 2y equals to 0, then you could say a 2y is a negative x, right? And then you divide by 2, y equals a negative x over 2. So you could just graph that line that has a slope of a negative 1/2. That's what that is, a negative 1/2 slope. And so that meant the line has a negative 1/2 slope. I'm just making that line right here. That's all it is. Okay. But I chose to do, I chose to plug in a 1 to see what happened. Wait, that's not negative slope. Sondos, why didn't you tell me that's not a negative slope? Negative slope. Come on. Get rid of my line. There, one more time. There you go. Now it's positive slope. I got to go. Remember, I just found this point at 1 negative half. It has to go through here. Negative 1/2 slope. There it is. Okay. So there's the line. You could graph it if you wanted to, just, by normal means. I just plugged in a 1 to see what another point was. And I got a negative half. Okay? It doesn't really matter about that point. He just cares about this line. He just cares about, I'll make it straight. He just cares about that line, which is y equals negative 1/2 x. Anyway, what's he saying? Find all the 6 trigonometric functions of the angle in standard position if the terminal side of theta is defined by this. And I need one more thing. I didn't finish reading. He wants the x's to be greater than 0 or equal to 0. So which triangle do I want? Do I want this triangle or do I want this triangle? Do I want left or right?
Right.
I want the right side because that's where the x's are. So I want this triangle right here. Now, what else do I want? Did he give me anything else? Well, I'm not comfortable because he didn't give me a point. He didn't give me a point. So I'm kind of like, I'm a hostage now. So we got to think about what point could I use? And your answer could be any point, maybe. A minute ago, I used a 1. What if I used a 2? I could use a 2. He didn't tell me I can't use a 2. He didn't tell me, as long as this angle will not change, I'm going to call it theta. This angle will not change. It doesn't really matter which x I choose to use. If I choose to use the 1, I'm here. If I choose to use the 2, I'm here. What would it be with a 2? If I plug a 2 in for the x, 2y equals negative x, that'd be a negative 1. If I chose this one, I'm at a negative half. But it doesn't really matter. I'll prove it to you in a minute. That's the theta. Sine of theta equals y over r. Oh, I don't know what r is. Depends on which point I want to use. If I use the first one, I mean the one here, the 2, because I don't want to use a fraction. So if I use the 2, then my triangle looks like this. My triangle looks like this. That's a 2. This is a negative 1. And I'm calling it negative just because you need to realize it's where it is. I don't know what r is, so I need to find r. R equals 2x squared plus y squared square rooted. R equals to 4, square root of 4 plus 1. Isn't that the square root of 5? If I choose to use that one. Did I do the math right? Please double check. Nobody? Sonos, I think you're the only one really in the class. Maybe cite Chin once in a while.
Square root of 5 is right.
Thank you. Okay. And if I chose to use the 1, I'd have a smaller triangle. That's all. This would now be a negative 1/2. This turned out to be a 1. So let's see what r would be now. Watch, watch. R equals to, this is still the right triangle, r equals the square root of x squared plus y squared equals the square root of x squared. That'd be a 1 plus y squared. 1/2 times 1/2 is 1/4. And it's going to be positive because it's squaring. Square root of 1/4. That turns into square root of, this is why I didn't pick this one. 4 over 4 plus 1 over 4 is the square root of 5 over 4, which turns into square root of 5 over 2. Because when you take the square root of the bottom, it turns into that, remember? So that would be what the r I would use if I chose to stop there, okay? Because when you change your triangle, you're changing the x's and the y's, so that's what's going to happen. I'll go back to the easier one. So square root of 5 is my r. Here goes. Sine of theta would be my y, which was a negative 1 over the square root of 5. Would I expect it to be negative? All students take calculus. Oh yes, sine's negative. Now the book is not going to use that answer. The book is going to rationalize the denominator. Times square root of 5 times square root of 5 gives you a negative 5, negative square root of 5 over 5. Personally, I don't mind this answer, but my math lab probably won't take it. Okay? Cosine of theta is the x over r, and my x, I calculated it to be, wait, did I do the right one? Oh yeah, what is the x? The x is 2. R is still square root of 5. Why is it positive? All students take calculus. Yes, cosine is positive. But the book's going to write this as 2 square root of 5 over 5. Tangent is y over x. That means it's a negative 1 over my 2. Just a plain negative half. I think so. Double check my math, somebody. I'll take it. Nobody's saying nothing. Okay, reciprocals. Reciprocal identities are called. Cosecant of theta. The reason I like my original answer, I don't want to flip this answer. If I flip this answer, then I got to rationalize again. Why don't I flip the first answer? Negative 1 over the square root of 5 becomes a negative square root of 5 over 1, which just turns into negative square root of 5. Secant of theta, I'm going to flip this answer. Square root of 5 over 2. And last one, cotangent of theta. I'm going to flip the negative half. That turns into negative 2. Okay? That was a hard problem. I think it's hard. Maybe you're just smarter than me and it's easy to you. All right, is there another problem on this page? Look at that, took all that room. Look at that, it's a lot of work. Finding functional values of quadrantal. Oh, this is actually easier. I'm going to give you a secret. Here's my secret. A unit circle. That means the radius is 1, the radius is 1, the radius is 1, the radius is 1. The only reason I'm telling you this is because I'm going to identify the ordered pair right here. That ordered pair is 1 to the right, 0 up and down. This ordered pair, these are quadrantal because this is 0 degrees. This is 90 degrees. That ordered pair is 0, 1. This ordered pair is negative 1, 0. This ordered pair is 0, negative 1. Now, you know how I told you how those special triangles are very important? When I start my calculus class, I review special triangles for a little bit. Then I review the unit circle. And what happens is, when you look at these, we know R is always a 1. So when I say sine of theta is y over r, then look at here. This is my x and this is my y. This is my x and this is my y. This is my x and this is my y. This is my x and this is my y. So when I say I want the sine of my angle, then the sine of 0 degrees must be 0 over the radius, which is 1. 0. My cosine of 0 must be, which is x over r. r is still a 1, but the x is a 1. So the cosine of 0 degrees is 1. The tangent of 0 degrees is y over x. So this is my y, this is my x. 0 over 1. I'm sorry, yeah, 0 over 1, which is 0. So I got 6 of them I can do now. The cosecant of 0 degrees is my, remember what that'll be, r over y. No, I'm sorry, r over y. R is always a 1. What's the y at 0? Uh-oh, 0. The cosecant of 0 is undefined. Take my word for it. I'm not going to give you a cosecant graph right now to prove it to you. I will later, but not right now. The secant of theta is of 0 degrees is r over x. So I go back to 0. That means 1 over 1. 1 over 1, which is 1. Which makes sense. The reciprocal of 1 is 1. But when you do the reciprocal of 0, it's always undefined. So when I do cotangent of 0 degrees, the reciprocal of 0 over 1 is 1 over 0, which is bad news. That would be also undefined. That was 6 of them for 0. Should I do one more with you? I'll do 90 degrees with you. 90 degrees with you. Theta is 90 degrees. Here goes. I'm going to do sine of 90 is y over 1. It's always over the 1 because r is 1. Y over 1 is 1 over 1, 1. Cosine of 90 is, and I'm going to give you a secret in a second here, is my x over the r, which is x over 1, which is the x 0. Okay? So I'm going to break some secret with you here. And don't tell nobody, because this is private information. If you really want to be a shortcut, the y value always is your sine when it's on the unit circle. This only applies to 0, 90, 270, and obviously 360 is the same as 0 because it's coterminal. So the sine of those angles is always the y. The x always stands for the cosine. So in essence, every one of those quadrantal angles means this is cosine of theta, this is sine of theta. Now tangent of theta is always going to be the sine of theta over the cosine of theta. Why? Because it's always y over x. So if you look at your ordered pairs, I'm not even going to do it anymore. I'm going to grab one. I want to know the cosine of 180 degrees as fast as you can do it. Cosine of 180. Oh, you guys dropped the ball. Cosine is the x. Bummer. Okay, try this now. Secant of 180, real fast. Secant. Come on. If I don't get more participation, I'm just going to do the videos at home and post them always, and you're just going to be watching them on your own.
It's also -1?
It is a -1 because it's the reciprocal of it. Thank you, Sonos. And that's why I said I think Sonos is the only one who's actually here all the time. Let's do the 270. Sine of 270 degrees as fast as you can. Sine of 270.
-1.
Yay, got another person. -1. -1. Who was that, by the way?
Trisha.
Trisha, nice job. Trisha, let me pick your brain here. What's cosecant of 270? As fast as you can.
0?
No.
Oh, wait. Which one was it?
We did a 270.
Oh,
And
is it -1?
yes, ma'am, it's the reciprocal. Nice, nice. I need somebody else. Tangent, real quick. Tangent of 270. Tangent of 270. I didn't write that right. My pen disappeared. 270. Tangent of this one right here. Tangent. Y over x. Y over x.
Is that undefined?
It is undefined. Okay, so I gave you a lot of stuff here. Look how much time I just spent talking about the unit circle. You need to spend another hour all by yourself. I'm not going to look at my picture no more. I want an angle of 90. He wants all 6. I'm not going to do all 6 with you right now. Well, I guess I will. I'm just going to write this ordered pair right here. That ordered pair is 0, 1. Remind you, the first number is your cosine. Second number is your sine. Your tangent is the sine over the cosine. So I'm going to write them out. Be thinking. Sine of 90. Cosine of 90. Tangent of 90. Cosecant of 90. Secant of 90. Cotangent of 90. Okay. Do you have enough time to think? Quickly, I need to hear more than one person. I want to hear the right answer from everybody. Sine of 90. Fast. Faster.
1.
1. I should have heard more than one person. Cosine of 90. Fast.
0.
Yeah.
0.
Tangent of 90. Fast, 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 fast.
Defined.
Undefined. Cosecant of 90. Think
1.
reciprocals.
-1.
Still 1. Good. I heard a couple people. Secant of 90.
0.
Undefined.
Okay, I heard a lot of people, and I don't even care that some of you were wrong. I don't care. I care that you tried. Remember, 0 stands for 0 over 1. Whoop, I'm on the right. Let me guess. My cap is loose again. 0 over 1. Take the reciprocal. The 1 becomes the bottom, so that becomes the undefined people win. Okay? Cotangent of 90. What happens if you flip the 1 over 0? That's what this was. What if you flip that?
0.
0. Yes. Okay. He wants all 6. That passes through -3. Why are we going back to that again? To me, we should have spent a lot more time on those. But anyway. We're at, oh, well, I see what he's doing. Look at -3, 0. -3, 0. This implies, guys, that on your unit circle, it's not a unit circle no more. Unit means 1. That just means your radius here is always a 3, right? This means your radius is always 3. I know the x is a -3. But in a circle, it still means a radius of 3. The x is -3. The y is a 3. So when I look at this, -3, 0, guess what I'm going to do? I'm going to have to divide by the 3 because I want all 6. Sine of this angle, by the way, the angle is still 180 degrees. Okay? So we're still looking at 180 degrees, believe it or not. Now, if you don't want to put the angle, you could say just, well, the sine of whatever angle that is, because he's calling it theta. But it's still 180 degrees, just like it was at the top. Now, look carefully. Sine is this is my sine right here if I divide it by the radius. So what is 0 divided by the radius of 3?
0.
Still 0. Interesting. Isn't it 0 over here too on this picture that I did over here? If I put this point -1, 0, isn't the sine still of 180 degrees still 0? Yeah, it is. Amazing. Cosine of this theta. Wrong picture. No, it's the right picture. Am I at the right picture? Yes. Cosine of theta will be this number, of course, divided by the radius of 3.
-1.
And look over here. Isn't the cosine of that 180 still a -1? Do you get the hint that it didn't matter what the radius was? Let me just ask you a question. If I'm down here, it doesn't matter what the radius really is. You can pretend that the ordered pair is still 0, -1, because it really doesn't matter. Well, I better not do that yet, because you might not believe me. So let me do, oh, wait, yeah, I'm doing tangent. Wait, why am I going down here? That wasn't even the problem. We're still over here. So if I do this, the tangent of theta was supposed to be my y over the x. My y is a 3. My x is a -3. And 3 over -3 is still a -1. But all I really cared that it was a 180 degree angle. So if I go back up here and look, this over this, oops, what happened? This number over this number still gave me a 0, didn't it? Tangent of 180 is still 0, right? Down here, wait a minute, how come I didn't get, oh, did I not do the right? It should be 0, that was 0. Shouldn't this be 0 also?
Yeah, I think
Oh,
you did something wrong.
I didn't use the right point, did I? It's -3, 0. Yeah, the y value is supposed to not be a 3. It was a 0 here, wasn't it? The y value is a 0, -3, 0. Yeah, it still should be 0. I don't know why I have this. It would have been 0 over a -3, which is still 0. Here's my point. If you're on the quadrant, who cares what the radius is? You can just forget that it's at -3, 0, because you know you're on the quadrant. Just pretend you're doing a -1, 0. And it's the same answers. They're the same answers. Maybe he's actually going to tell us that. Let's see. No, he's not. He's not giving you the secret. If the terminal side of the quadrantal angle lies along the blank axis, then the tangent and the secant functions are undefined. Okay, so here's the question. Tangent of what was 0? I think it was the tangent of 0 was 0, and the tangent of 180 degrees was 0. We just did that one right now. The tangent of theta was still 0. Tangent of 180 is 0. Oh, he doesn't want 0. He wants undefined. I'm sorry. Where were they undefined? So let me change this. That was where there's 0. He doesn't want 0. Well, where do you think the other two quadrants are? It would be 90 then, right? And
270.
thank you. You're faster than me. 270 was undefined because the x value is always going to be 0 right here. The x value is 0 and the x value is 0. So that's why you get undefined for both of those. So it's the y-axis. If you're on the y-axis, that's where your coterminal side is. On the y-axis, you're always being defined. And if the terminal side of the quadrantal angle is along the x, if the terminal side of the quadrantal angle lies along the what axis, then the cotangent and cosecant are undefined. Okay. That's a little harder. Cotangent means x over y, and cosecant means your radius, which is 1 over y. What do you notice? What makes it undefined? If the what? If the y's equal to 0, those are undefined. If the y is 0. Well, where is y 0 at? Here and here. That's the x-axis. Would I memorize that little bit there? No. It's just not worth thinking that hard. Look how hard I had to think. I had to think. And it's not really worth it.